For this section, we're going to be talking about solving when you have three equations and three unknowns. So, the process says that the first thing that you have to do is take two pairs of the three equations. So, for instance, the first and second, and then the second and third equations. And you want to reduce them to just two equations with two unknowns by eliminating the same variable from each pair. So in that example, say if you pick the first and second and third, in each of those pairs you will add them together using the addition method, for example, to eliminate the variable x. And when you do, you'll be left with just y and z in two equations. And we do that because now you can solve that pair of two equations, two unknowns, using the addition or substitution method like we've done previously. And once you find the two values using the addition or substitution method, you'll now be left with just one of the original three variables to solve for, and you can find it by plugging those two values into one of the three original equations to solve for that third. And when you get it, you give your answer in the form x, y, z, in parentheses. Just like before, we gave our answers as parenthesis x, y, parenthesis. Well, we give it in this form with these types of problems because now this is what we call a three-dimensional point. As you get through mathematics, you'll study more and more about three-dimensional spaces, but for right now, this is usually your first introduction to it. So, starting this off, we have the problem x plus 4y minus z equals 20, 3x plus 2y plus z equals 8, and 2x minus 3y plus 2z equals negative 16. So to solve this, the first thing that we want to do here is decide which of the variables, x, y, or z, would be the easiest to get rid of. Getting rid of x isn't very easy because neither of these equations matches up, meaning we'd have to multiply all three of them by something in most cases to get rid of something. Technically, you could just multiply the first equation both times, but essentially, x is going to be a little tricky. Y is going to be very tricky because none of the y's has just a 1 in front of it like the x did. But generally, the easiest one here in this problem is going to be eliminating z. The reason for that is right away you can eliminate z from the first two equations by adding them together. You don't have to multiply anything. So, it doesn't matter which one you pick, it's just generally you want to look for the easiest one. So, we're going to go ahead and eliminate z in this example by first noting what these equations are. So we'll list them as 1, 2, and 3. This way, whenever we perform an operation on them, we can just say we're going to multiply 2 times equation 1, for instance. This way we don't have to write all that out every time. It's a way to show our work quickly. So for instance, in our first step, we're going to say equation 1 plus equation 2. We are adding these first two equations together to eliminate the z. So we get x plus 4y minus z equals 20, and 3x plus 2y plus z equals 8. We're not multiplying by anything, we're just adding them together. So x plus 3x gives us 4x, 4y plus 2y gives us plus 6y, negative z plus z cancels out, and that's equal to 20 plus 8 is 28. And we will call this equation 4. Okay, so from here, we now need to find a second pair of the equations to add together to cancel out z again. We have to cancel z both times we do this. So in this case, the next easiest pair to eliminate would be equation 1 with equation 3, because they already have opposite signs. You won't have to multiply by a negative. You will have to multiply equation 1 by a 2 though. So we'll say 2 times equation 1 plus equation 3 gives us 2 times equation 1 will be 2x plus 8y minus 2z equals 40. And equation 3, we can just copy that down. 2x minus 3y plus 2z equals negative 16. And adding these together, 2x plus 2x is 4x. 8y minus 3y is plus 5y. Negative 2z plus 2z cancels out. And that's equal to 40 plus negative 16 gives us 24. And now this is equation 5. So once we find equation 4 and equation 5, we want to use them to solve for our two variables, x and y. And again, I know I keep repeating this, but these two variables have to match for this to work. So we'll now copy this below equation 4. So 4x plus 5y equals 24. And the easiest way to solve this will be with the addition method. We just have to multiply this equation by a negative on each side, which will allow us to cancel out the 4x in each equation. So we get 4x plus 6y equals 28. And in the bottom equation, we have negative 4x minus 5y when we distribute the negative equals negative 24. Combining these terms, 4x minus 4x gives us 0. They cancel out. 6y plus negative 5y gives us just y. And that's equal to 28 minus 24 is 4. So we now know what y value solves this equation. Y equals 4. Now we use that to find the x value. We can use either equation 5 or equation 4 to find the x value. I'm just going to go ahead and use equation 5 since I have space underneath it. So we have 4x plus 5 times 4, we're plugging in 4 for y, equals 24. So 4x plus 20 equals 24. We'll subtract 20 from each side to give us 4x equals 4. And finally, divide each side by 4 to get x equals 1. Now that we have y and x, we can solve for z. And we want to use one of the original 3 equations, and we're going to use equation 2 because it already has z by itself. We won't have to divide or multiply by anything to get z alone. So we have 3x plus 2y plus z equals 8. So that gives us 3 times x is 1 plus 2 times y is 4 plus z equals 8. 3 times 1 is 3 plus 2 times 4 is 8 plus z equals 8. 8 3 plus 8 is 11, plus z equals 8. Subtracting 11 from each side, and we get z equals -3. So our solution is x comma y comma z in parentheses. So we have 1 comma 4 comma -3. That is the solution to this system of equations. All right, so we just have one more of these to go through. Go ahead and take a moment, pause the video, see if you can't solve 2y minus z equals 7, x plus 2y plus z equals 17, and 2x minus 3y plus 2z equals -1. All right, so trying this together, the nice thing about this problem is equation 1 already has one variable eliminated. So we can already count that as equation 4. When we list these 1, 2, and 3, remember you always want to do this, we can immediately just say, let equation 4 be the 2y minus z equals 7. Which means we now just need to combine equation 2 and equation 3 to get rid of the x's. So what would you have to multiply by? Well, we need the x's to be opposite, so we need to multiply equation 2 by a -2. So we get -2 times equation 2 plus equation 3. Multiplying equation 2 by -2, we get -2x minus 4y minus 2z equals -34. And now we just copy down equation 3, 2x minus 3y plus 2z equals -1. Adding these together, -2x plus 2x cancels out. -4y minus 3y gives us -7y. -2z plus 2z cancels out, and that's equal to -34 minus 1 is -35. And now notice what happened here. We eliminated two variables, which means we can now immediately solve for the variable y. We'll divide each side by -7, which gives us y equals 5. And since we know y, and we have an equation with just y and z, we can plug this in to find z. So we get 2 times y is 5, minus z equals 7. So we have 10 minus z equals 7. Subtracting 10 from each side, we get -z equals -3. And finally, dividing each side by -1 or multiplying by -1, either way, we get z equals +3. And now that we have z and y, we can solve for x in one of the original equations. So, we want to pick equation 2 in this case because the x is already alone. We won't have to divide or multiply by anything to get x alone. So we have x plus 2y plus z equals 17. So we have x plus 2 times y is 5 plus z is 3 equals 17. Which gives us x plus 10 plus 3 equals 17. Simplifying, we get x plus 13 equals 17. And subtracting 13 from each side, we get x equals 4. Remember, we give our solution as a point. So we have 4, comma 5, comma 3, x, comma y, comma z.